Good morning, everyone. Today, I'd like to talk about aerospace materials testing. So, the last time we learned about the history of the aviation. We know the a lot of the efforts the peoples have taken during the history time, and then this time is very important for that. Why we should do a lot of tests, and then why we should get a lot of data for the aerospace materials. So that is the reason for that when we develop the materials. For example, when you develop the new materials by using the AI, and then maybe you can suggest the kind of the alloying components, alloy elements, and then you can fabricate it. Even though you made it a new one, and then actually you realize that that has a very high strength and high elongation and very good fracture toughness and then very good fatigue properties. So that maybe you got some of the results for that specimen. Maybe you had maybe the three times as test is conducted, and then you can just suggest it. How about to use this specimen? But in that case, it is very difficult to use in the aerospace materials because we need a lot of data for that. The data should be means like the statistical data. So the not just for the one or two data it is satisfied. You should satisfy the 10 hit and 10 lot, and then at least the 300 data for that. Even just you conducted the tensor test. So the in this case, let's see about this part. So the at first time, the material screening and selection and the material specification development, allowable development, this is the material property evaluation. So at first time, you need to do a lot of the work for the test. And after that, you can just go to further like the structural, elemental tests and sub-component tests. But this time, for the components, not just for the material, so you don't need to do it. And after that components of full scale test, it means that it is the full body of the airplane. So that this is the final stage. But in the first time, at the bottom of this pyramid, it is a lot of the test and the data should be required. This is kind of example for that. If it is a non-critical component, how long it will take about the development time? It is around 2 to 3 years. You should do a lot of the tests to get the statistical data, and it is not a non-critical one, so you don't need to worry about the A basis or B basis, things like that. But if it is very critical for one, it is up to 4 years because it should be satisfied A basis. A basis means like the 95% confidence level, and then it should be satisfied the 99%. So it is very difficult to do it. So and then new material, but other things that already existed materials. So for example, like a Thai 64, it is we just buy from the abroad, and then it is not imported from the other countries, and then we don't have we also already have the Thai 64 in domestic, but it is not qualified. And in that case, we should do a lot of tests, even though it is already developed materials. But in your case, for example, you develop the new materials like using the AI, then this is should be certificated a lot of the things like that. So it will take up to 10 years, includes time to define materials composition and processing parameters. So it takes so long time. So the development of the new materials is very difficult in the aerospace materials case. And new material class, and it is up to 20 years or more. So you should spend a lot of time, and then you should spend the lifetime in your life. But I believe that it is nowadays it is reducing because of the autonomous. So nowadays the testing, the robot can do the test. So if for example like the tensile test, the robots can do the very basic stage of the test. They can do it, so they can do a lot of tests. And for that, but testing is not a big deal. But making the specimens and or making like that samples, making the materials. 10 hits and 10 loss means like and when you have the cast the samples, and then one hit means the um, one cat when you cast the samples, the one hit means that is the first charge and second charge and third charge, things like that. But should be the commercial one. So even though the first charge is not the 1 kilogram or 2 kilograms, it should be go to the tons, like the 1 or 2 tons. So it is really the commercial case. So if you make the 10 hits, it means that 10 casted charges of the samples. It is a lot of money. So that is very difficult part for the certification new material system in the aerospace materials. So validation is very important. So it should be validated by the test. A lot of tests should be conducted. So airplane structures of standardization by analysis based on loads and deflections and validated by the test. So it should be go for the subparts is structure in strengths requirements are specified in terms of limit loads and maximum loads to be expected in service, and if deflections under load would significantly change the distribution of external internal loads. This redistribution must be taken into account. It means that we need a lot of the tests for these cases, and the proof of structure analysis maybe should be structure, and then experimental should be in the method in reliable. So the reliability is also important. So these kind of requirements, and they should satisfy with that. So there are a lot of data for the airframe design. So the things like that, the physical properties, you can think about the density is very important. So the lightweight is important, and also thermal expansion, heat capacity, thermal conductivity, Poisson's ratio, tensile compression, shear, and bulk modulus. You should get the data for this part. And also static mechanical properties. Tensile, so there are four things: tensile, compressive, and shear, and bearing. So there are four major static mechanical properties, and durability and the damage tolerance properties is like the fatigue and the notch sensitivity and crack growth toughness, and then other special design factors. So usually the fatigue properties are very important, and also environmental effects, the temperature, humidity, then chemical resistance, the wear, corrosion resistance, oxygen resistance. So nowadays the environmental conditions are getting very harsh, and the temperature, the change is a lot, and then we experience a very hot summer and a very cold winter, and also the kind of the disasters from the sea on the oceans. So that the environment effects are very important. And producibility and we should castability and formability and deformation characteristics. Weldability is also important. Machinability, assembly, chemical processing, inspection methods. So inspection is like usually the non-destructive instructions they can do, and certifications, the material spec and the specs and the process and other things, approve the suppliers list, things like. So there are a lot of the material data required for the airframe design, not just for we have already conducted tensile test. We got the very high stress and then high elongation. That is not a big deal. So there are a lot of the test data are required for the airframe design. That's the thing. So today I will talk about the role of testing, the material tests. So there are a lot of tests. So the design and then construction, and also the control of the established processes, and also things like that, and then common test method, and then applicability of the data, and I will explain. So at first, the types of material testing. So the first one is the commercial testing. So commercially we can do that. So checking acceptability and the standard procedures, and there is not a so not so difficulties about to do these tests. So the commercial test already is established, so that we can do it. And material research testing. So the to obtain new understanding of non-materials. So the we want to know the new properties and also the characterization of new materials, development of the new or refine existing test standards. So that we can develop the new test standards also. So the scientific testing we can do it. So the test, to field the test, so you can conduct it in the outside and in the location like the flight line and then also the construction site. So it is in the field, so it is low precision and comparing to the laboratory test. Laboratory test is very specific and precise. But the field test is very important. It is actual one, and actually, when it is also conducted in the actual environment, so field test is very important. And also laboratory test, you already had experience for this part. So the test done in the laboratory, and then there are the controlled conditions, and typically the more expensive than the field test. It is a very complicated one, and then but it has a very greater precision than the field test. So the laboratory test is the same condition. We can do it. We can control the condition. And one more thing is that another thing is destructive and non-destructive. Categorized into two things. Destructive is eventually, finally, the specimen is broken, so breaking or damaging the sample. So we can do it the test before that the fabrication, but when it is going for the finishing part, so for example, like it is already be in that airplane, we cannot just cut the samples. So for example, like the tensile testing, hardness is also it is destructive one. Fatigue testing is also failure. So these things are very effectively understand that the phenomenon and then behaviors, but that the disadvantage is we cannot just conduct for the finished parts. Comparatively to the destructive one, non-destructive. So it is do not damage samples. Before the test and after the test, the sample is the same. So same condition, and often used for the quality control. It is for example like the proof testing, radiography, micro hardness testing. So it is not destructive, and then it is you can safely we can understand. Non-destructive test is very important in the aerospace materials, and the structural test and then done on the components and structures, and coupon tests are like for the level for the materials. So for example, like when you do the small size of the tensile test specimens, that is the coupon test for the materials level. And significance of the test. The concept is important, and or test condition and the method, and so the documentation is very important for that test. So when you do the test at first time, when you make the documentation, and then after that other guys can follow it, so how can do the test. So it is very always the same, and then it should be consistency is very important for the test. And uncertainties in data, so we need to understand that there are some artifacts and then some errors, and we need to understand if you do the test and step by step you should take the photo and then check the steps, and at first time you can observe the samples, and then you can go to the next step and then take the photo and then just write down what happens during the test. That is very important. And significance of the test measured by precision, reliability. So in the other people, they can do it, and then they can have always the same properties, not the same properties, but the same method. They should do it, and reproducibility, and then they should do the same thing like this. And accuracy is also important. So the test can be very precise but not accurate. So the precise test is very important, and the accuracy is not always go to the accuracy. If there is the true data, like the true data is, for example, like the 100, we can assume that. But one time you can get the one 101. On other times you can get the 99, but it is not the. We can say that is a real data. So the data is data. So the if the when the test is very precise, you don't need to worry about that accuracy. So material properties, so the mechanical ones, it is microstructurally sensitive. So they starting from the subatomic to the atomic level, molecular, micro, and the macro level. We can do it, and then physically, and then they could microstructure insensitive. That in, so the mechanically, microstructurally sensitive. So the strength and ductility and the fracture toughness. We need to understand microstructure a lot. But other things is physical one. Physical one, the microstructure is not big deal, and then it is already fixed the data. So the most of cases we are doing the test for them mechanical testing for because we can control the microstructures. Okay, so the stress conditions, and the stress condition is the next time we will do it, and then there is the axial tension and compression, bending and shear and torsion, things like that. And the next time, so we will learn the in deep inside about the tensile loading and the load cell about the test method. So the this is the introduction for the aerospace material testing. So we understand that why we need a lot of tests for the development of the aerospace materials. So yeah, that is the main topic in this lecture. So okay, let's call it a day, and then see you next time. Okay.